Okay, today we will start chapter 5, the series. So before we go for the series, we need to do a quick revision for sequences because sequences is related to the series. So we will start by revision the sequences, and then we will start by the series, and we will go how to find the sum of the series and how to test the convergence of the series. We have 3 tests, and then we will go for power series and how we can write some function as a power series. And finally, we have special cases of power series, which is Taylor and Maclaurin series. So we will start by doing revision for sequence. We will start by doing revision for sequence. Sequence means any order of numbers. Any order of numbers, we call it sequence. For example, you see my screen, right?
Yes.
Yes.
Okay. So, for example, if I write 1, one, 2, 3, 4, 5. This is a sequence. 1, 2, 3, 4, 5 is a sequence. Or for example, when I say 1, if I say 1 over 2, 1 over 3, 1 over 4, this also a sequence. Or for example, if I say 0, 1, if I say 0, 1, 0, 1 is also a sequence. Or for example, if we say 3, 9, 27, 81, and so on, this is a sequence. Any order of numbers, we call it a sequence. Any order of numbers, we call these numbers as a sequence. Or for example, 2, 4, 6, 8, 10, and so on. So these are all a sequence. Any order of numbers, we call it a sequence. 1, 2, 3, 4, 5, 1, 1 over 2, 1 over 3, 1 over 4, 0, 1, 0, 1. All are these examples of a sequence. In case we stop, for example, the first one, 1, 2, 3, 4, 5, if I stop for one number, for example, 10, then we call this finite sequence. If I stop at one number, we call it finite sequence. Or here, for example, if I stop at 1 over 12, then we call, because we stop at one number, then we call this a finite sequence. In case that you didn't stop, you just continue, this is we call infinite sequence. So we have 2 types of sequence: finite sequence and infinite sequence. Finite sequence means that you stop at one number. Infinite sequence means that you go until infinity. You didn't stop. Then we call it infinite sequence. For each sequence, we have something called the nth term. The nth term. Look for the first sequence: 1, 2, 3, 4, 5, 10. This sequence. If we go for this sequence, no. Okay, if you look for this sequence here, 1, 2, 3, 4, 5, the nth sequence for this one, we call it n. And here is the nth term, which means the first term will be 1. N equal to 1, which is 1. The second term is 2. The third term is 3. The fourth term is 4. The fifth term is 5, and so on. So this term, or this one, is called the nth term. It's called the nth term. For the second sequence, the nth term will be 1 over n. The nth term will be 1 over n, which means a1 is 1. Maybe can describe it better if I for example, if I take 1, 2, 3, 4, this sequence, when I say this is the nth term, which means for any one I can find an. For example, for a1, I need to substitute n equal to 1, which is 1. a2, I need to substitute n equal to, which is 2. For n3, I need to substitute n equal to 3, which is 3. Another one, you still can see my screen or not?
Yes.
Because I changed the file, I'm not sure. Okay. For example, the second sequence, when I say about 1, 1 over 2, 1 over 3, 1 over 4, and so on, then a1, which means 1, a2, the nth term is 1 over n. So when n equal 2 is 1 over 2. When n equal to 3, it is 1 over 3. When n equal to 4, it is 1 over 4. So we substitute n by the term. So a1 is when n equal to 1. So substitute n equal to 1, you will get 1. If I need the second term, you need to substitute n equal 2, which is 1 over 2. If you need to find the third term of the sequence, you need to substitute n equal to 3. These kind of sequences, we call it, this is the sequence, this is what we call the nth term of the sequence. The nth term of the sequence. We have two types of sequences. We need to focus here. The first one, we call it arithmetic sequence. The first one, we call this one arithmetic sequence. Arithmetic sequence, which means, for example, if we go for this sequence, 2, 4, 6, 8, and so on, which is 2n sequence. 2n sequence. This sequence, we call it arithmetic sequence because we keep adding the same number. We keep adding the same number. For example, 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So we keep adding the same number. So this sequence, we call it arithmetic sequence. Arithmetic sequence. Which means you keep adding the same number. You keep adding the same number. To find the nth term of this sequence, you need to follow this rule. You need to follow this rule. A1 plus n minus 1d. A1 plus n minus 1d. This is the rule how to find the nth term. Okay, what is the meaning of A1 and d? A1 here is the first term. The first term is 2. The first term is 2 plus n minus 1d. D here is the number you add. Here we add 2. Here we add 2. So you have 2 plus 2n minus 2, which is 2n. Which is 2n. So this is the nth term. This is the nth term. So to find the nth term for arithmetic sequence, you need to follow this rule. A1 here is the first term of the sequence. In our example, the first term is 2. D is the number you keep adding. This is what we call arithmetic sequence. If we go back to our lecture note here, this is example for finite sequences 1, 3, 5, 9. 1, 2, 3, 5, 9 until n. This is also finite. 1, 1, 2, 3, 5, 8. This is infinite sequence. So for arithmetic, for example here, 8, 5, 2, minus 1, and 4. Here the first term is 8. D is minus 3. We keep subtracting minus 3. You keep subtracting minus 3. You keep subtracting minus 3. Minus 3. So which means that your A is equal to 8. Your A is equal to 8. And D is equal to minus 3. To find AN, you need to apply the rule A1 plus N minus 1D. You need to apply this rule. Okay. A1 is the first term of your sequence. The first term is 8. The first term is 8 plus N minus 1. D here is the number you keep adding or you subtract, because here we keep subtracting 3. So D here is minus 3. Is minus 3. D here is minus 3. So 8, which is equal to 8 plus 3n plus 3 minus 3 answer. Because we have minus 3, so this should be minus 3n. Should be minus 3n. So this one will be equal minus 3n plus 11. Plus 11. So an will be a1 plus n minus 1d. This is only for arithmetic sequence. For arithmetic sequence, you keep adding the same number or subtracting the same number. Then an will be a1, the first term, 8, plus n minus 1d, d the number you keep subtracting or the number you keep adding. Here we keep subtracting minus 3, so d is minus 3. From an, I can compute or evaluate any term in the sequence. For example, if I need to evaluate the 100 terms, 100, I need to know the value of the 100th term of the sequence. Just substitute for the nth term by n equal 100. You get the value of the 100th term, the term that have the 100th term of the sequence, the 100th term of the sequence. If you need to find the first term, you need to be sure that the first term is 8. Make n equal to 1. So 11 minus 3 should be 8. The second term, you need to be sure it is 5. Just substitute n equal 2. So 11 plus, substitute n equal 2, you have minus 6. 11 minus 6, which is 5. So this is how to be sure that you have a correct nth term. Then you can calculate A100, A1000, A99, any term of your sequence. This is the arithmetic sequence. The second type of sequence, we have geometric sequence. Geometric sequence. For geometric sequence, for example, 2, 6, 18, 54. This sequence, we keep multiplying the same number, not adding. Here we keep multiplying the same number. Here we keep multiplying 3. So we keep multiplying the same number. So keep addition the same number, arithmetic sequence. Keep multiplying the same number, we call it geometric sequence. So how we can find the nth term of geometric sequence? You need to follow the rule AR. You need to follow this rule. AR to the power n minus 1. For example, here, if I need to find an, the first term, I need to apply AR to the power n minus 1. The first term is 2. R here is the number you keep multiplying. We keep multiplying 3, so R is the 3. So 2 to the power 3 and minus 1. And minus 1. Same for the second sequence. Second sequence 1, minus 2, 4, minus 8. Then this is, we keep multiplying minus 2. We keep multiplying minus 2. Since we keep multiplying minus 2, our R here is minus 2. Our R is minus 2. And our first term is 1. Our first term is 1. R is minus 2. So to find the nth term, follow the formula for geometric series, which is AR to the power n minus 1. A here is 1. R here is minus 2 to the power n minus 1, which is minus 2 to the power n. So generally, you have two types of sequences: arithmetic sequences, geometric sequences. Arithmetic sequences, we keep adding the same number. Geometric sequences, we keep multiplying the same number. How to find the formula for arithmetic sequence? You need to apply the formula an is equal to a1 is equal to a1 plus n minus 1d. This is the formula for arithmetic sequence. What about geometric sequence? This is the formula. an is equal to ar to the power n minus 1 to the power n minus 1. But be careful, not all sequences can be arithmetic or geometric. Some sequence not arithmetic, not geometric. Some of the sequence not arithmetic, not geometric. But in case if you have arithmetic sequence, you need to apply this formula to apply the nth root. If you have geometric sequence, you need to apply this formula to find the nth term. To find the nth term. Okay, series. This is a quick revision for sequences. So now we need to start off the series. We need to start off series. What we mean by a series? When I'm talking about the series, what is the series? Okay, for each sequence, we have a series. For each sequence, we have a series. Let us go back to maybe here. Okay, series. If I'm talking about series, for each sequence, for example, this sequence, for each sequence, we should have a series. When we add this sequence, here for the sequence, we just have order of numbers. But for the series, I need to add these numbers: 1 plus 2 plus 4 plus 5. This is a series. This one is a series: 1 plus 2 plus 3 plus 4. So series is adding the term of sequence. Series is adding the terms of sequence. If you have a sequence is just order of numbers. Series, you start to adding these numbers. So how many terms you have to add? We have partial sum, something we call it partial sum. For example, if I need to find S1 or sum 1 or summation 1, S1 means that only the first term, which is 1. Okay, if I'm talking about the second term, if I need to add 2 terms, I will make it S2. S2 means 1 plus 2. You need to add the first 2 terms. S here means summation or sum. The number here means how many terms you need to add. From your sequence. So S1, the first number. S2 is you need to add the first 2 numbers. 1 plus 2, which is 3. 1 plus 2, which is 3. If I need to find S3, you need to add 1 plus 2 plus 3, the first 3 terms of your sequence. The first 3 terms mean 1 plus 2 plus 3, which is 6. So generally, we say that Sn, you need to add the terms from 1 until n for this sequence. From 1 until n. Another example. For example, if I take the sequence 2, 4, 6, 8, and so on. This is a sequence. Now, for this sequence, we have a series. 2 plus 4 plus 6 plus 8. This is a series. When we add the terms, this is a series. Okay, if I need to find S3 means you need to add the first 3 terms of your sequence. So you need to add 2, 4, and 6. 2 plus 4 plus 6, which is 12. If I need to find S2, means that you need to add only the first 2 terms, which is 2 plus 4, which is 6. If you need to find Sn, you need to find the nth term. So S means you need to add, this is a series, this is a summation. The number here, how many terms? The number here is how many terms you have to add. Another example, if I have the series 3, this is a sequence of 3, 7, 9, 11, for example. This is a sequence. Now, for this sequence, we have a series. 3 plus 7 plus 9 plus 11. When you add, become a series. To find S2, which means that you need to find the addition for the first 2 terms. First 2 term is 7 plus 3, which is equal to 11. If you have any question, you can ask on the chat or you can open your mic. Okay, going back to our document here. So we have a series 1, 2, 3, 4. S1, the first term only. S2, we need to add the first two terms, 1 plus 2. S3, you need to add 1 plus 2 plus 3. We need to add the first three terms. Okay, foregoing the example, if I need, we have a sequence here, 1, 4, 7. We need to find the fourth term and fifth term of this sequence. What is the fourth term here? I need to find the fourth term. First, this one is arithmetic sequence or geometric sequence? 1, 4, 7. Is it arithmetic or geometric? Yes.
Arithmetic.
Arithmetic sequence. Yes, we keep adding 3. We keep adding 3. 1 plus 3 become 4. 4 plus 3 become 7. So to find the fourth term, 7 plus 3 will be 10. Will be 10. To find A5 fifth term, you need to add another 3, which is 30. Which is 30. If the question asks you to find, for example, the 12th term or the 100th term or some large number, you need to find an first. We need to find the nth term first. Because here, if you need to find an in generally, because this is arithmetic sequence, it will be 1, the first term, and plus 1 times 3. 3 is the number you keep adding. This is the nth term. This is how to evaluate the nth term, which is equal to 1 plus 3n minus 3, which is 3n minus 2. 3n minus 2. So this is how to find any term. Then you can find any term. Okay, now as a series, we need to find S4 and S5. As a series, we need to find S4 and S5. S4 means you need to, S4 means that you need to add 4 terms. S4 means that you need to add 4 terms. So S4, I have to add the first 4 terms. The first 4 terms. The first 4 terms, 1 plus 4 plus 7 plus 10. The first one. So you have 1 plus 4 plus 7 plus 10, which is equal to 22. Which is equal to 22. So you add the first 4 terms. S5, you need to add the first 5 terms. So 1 plus 4 plus 7 plus 10 plus 13. The series S5. S5 is a series. S4 is a series also. So S5 is a series by adding the first 5 terms. The first 5 terms here. So you need to add 1 plus 4 plus 7 plus 10 plus 13, which is 35. Which is 35. Okay. Another example, the sum of the first, here we give you the Sn. How you can get the Sn of the series? 1 over 4, 5n squared plus 11n. We didn't give you the sequence, we give you the series. How to find the series S1, how to find the series S2, how to find the series S3, and so on. And from this one, we need to find the first 3 terms. The first 3 terms. So the first 3 terms here, from the sequence. We need to find the first three terms from the sequence itself, because this is a series, which means it comes from one sequence. To find the terms of the sequence, you need to find S1. S1, 1 over 4, 5, you need to substitute n equal to 1. You have to substitute n equal to 1. So 5 plus 11, which is 4. Which is 4. So the first term of your sequence should be equal to 4. For the first term of your sequence should be 4. Now I need to find the second term of the sequence. So I need to evaluate S2. But be careful, S2 means the addition between the first term and second term of the sequence. The addition between the first term and second term. Because S2 means we add the first two terms. So we need to find S2, you need to substitute here by n equal to. So you have 1 over 4, 5, 2 square, which is 4, plus 11 times 2. So if you evaluate this one, it will be 10.5. 10.5. So S2 is equal to 10.5. And A1 is equal to 4. So A2 should be 10.5 minus 4, which is 6.5. 6.5. So this is the second term of the sequence. So the first term, A1, 4. A1, 4. A2, A1 we have 4. A2, 6.5. 6.5. Okay, to find A3, you need to find S3. You need to find S3. S3, you need to substitute. You need to go back for the formula here and substitute n equal to 3. So 1 over 4, 5, 3 squared, plus 11 times this. We have to go back and substitute n equal to 3. So if evaluate this one, it should be equal to 19.5. 19.5. Okay, so S3, 19.5, which means that A1 plus A2 plus A3 is equal to 19.5. So I need only A3. So A3, in this case, the third term of the sequence should be 19.5 minus the first term A1 and the second term A2. So minus 10.5 minus S2. So this should be equal to 9. Because S2 is A1 plus A2. So you need to subtract S2 from S3 to find A3. So A3, 9. So your sequence, the first three terms of your sequence is 4. This is your sequence. 4, 65, 9. 4, 60.5, and 9. This is the first three terms of your sequence. You need to find the nth term. Nth term of the series, same as nth term of the sequence. So the question is, this sequence you have, is it arithmetic or geometric? 4, 6.5, and 9.
Arithmetic.
Yes, arithmetic 1. No, this is arithmetic 1 because we keep adding the same number. Geometric means we keep multiplying the same number. Here we keep adding 2.5 plus 2.5. plus 2.5. So you keep adding the same number. So this is arithmetic. Geometric, you keep multiplying the same number. So different. So it is different. So here, this is arithmetic. So we need to find based on the formula of arithmetic, an is equal to a1 plus n minus 1d. a1, the first term is 4. n minus 1. D here is 2.5. D here is the number you keep adding, which is 2.5. So which means 4 plus 2.5n minus 2.5, which is 2.5n minus 1.5. This is the nth step. This is the nth step. This is the nth. Usually the series we use this symbol or this notation, this sigma or summation here, for series. Only for series. If you see this symbol or this sigma, this means this is a series, not a sequence. This is we mean summation. We add. So this is a series. Series, we add the terms. Sn can be written as the summation of the terms starting from the first term, finish at the nth term. Finish at the nth term. So this is the symbol or the donation we use to highlight this is a series, not a sequence. Not a sequence. In case of infinite, we write here infinite. We keep adding until infinite. Okay, example 5.3. We need to find the rth term of the following series. Hence, we need to write it as by using this symbol of this notation. Okay, the first series 2 plus 3 plus 4 up to 10 terms. Up to 10 terms. 2 plus 3 plus 4 up to 10 terms. So first we need to check our sequence. Is it arithmetic sequence or geometric sequence? You need to check first. Okay. You have for number A, this is your sequence. This is your sequence. This is the sequence we add. We have 2 plus 3 plus 4. This is a series. 2 plus 3 plus 4. This is a series. The original sequence 2, 3, 4, 5, 6. We add this sequence, we have a series. Now this, if I find the nth term of the sequence, then we found the nth term of the series. So this sequence 2, 3, 4, it is arithmetic sequence because we keep adding the same number 1. 2 plus 1, 3. 3 plus, here we keep adding plus 1. Plus 1. So we keep adding the same number. We keep adding the same number. So you have to find an based on the arithmetic formula, the first term, which is 2, plus n minus 1, the number you add, which is 1. So 2 plus n minus 1, which is n plus 1. Which is n plus 1. So this is the nth term for the series or for the sequence. So you need to write our series now in terms by using this symbol. So here up to 10 terms. Up to 10 terms, which means you need to add n plus 1. You need to add the nth term, this one. N plus 1, this term, n plus 1. You need to add from 1 until 10. From n equal to 1 until 10. Until 10. Because we need to add up to 10 terms. We need to add up to 10 terms. So this is the counting. This is from n until 1 until 10. This is the counting. How many terms you need to add. Yes, the question asks R, so you can replace N by R. Just okay, because the question asks the R term, so just here you need to replace N by R. Can replace N. For this one, you can also replace N by R. So become AR, R minus 1, R plus 1. So it become a. This is the nth, the rth term. The rth. Okay. For okay, now this number B minus 3 minus plus 9 minus 27. Also, this is a series. I need to write this series using this symbol by this way. I need to write the series using this way. So, same. First, we have this series. Okay. We have minus 3 plus 9 minus 27 and so on. This is the series. So we need to first write your sequence. Write your sequence. This is the original sequence. We add this sequence, so we have a series. Now, to find the rth term of the sequence or of the series, we need to specify the type of this sequence. Minus 3, 9, minus 27. This one, geometric or arithmetic sequence?
Geometric.
This one, geometric, yes. Because this one, we keep multiplying minus 3. We keep multiplying minus 3. So we multiply the same number. Since we multiply the same number, this is a geometric. So this is a geometric means you need to follow the formula of geometric. The formula of geometric. The formula of geometric, the first term A1, R to the power n minus 1. Okay, the first term is minus 3. Sorry, this is, again, this is R, sorry. This should be R. This should be R. So minus 3, R also minus, the first term is minus 3 and R also is minus 3 to the power n minus 1. So it is minus 3 to the power n. Minus 3 to the power m, to the power R. But here, okay, this one, call it any number m to the power r minus 1 to the power r minus 1, this to the power r. So yours will be minus 3 to the power r. Now we need to write as a series. So will be summation or sigma up to, according to the question, I think up to 30 terms, right? Until 30 terms. So R will start from 1, from the first term, until 30 terms. To minus 3 to the power. Minus 3 to the power. Okay. The sum of the series. The sum of the series. How to find the sum of the series? Some series, we know how to find its sum. For example, if I have the sequence 1, 2, 3, 4, n until m, and we need to find its series 1 plus 2 plus 3 plus n, the summation finally is equal to n plus 1 over 2, which means if you add only 2 terms, n will be equal to, this is Sn. This is Sn. If you need to find S2, you need to add the first two terms, which means n equal 2. If you need to find S3, the addition for the first three terms, you can apply this formula, 3 plus 1 over 2. This is the formula of the series R square. 1 square plus 2 square plus 3 square plus n square. This is a series. The original sequence, 1 square, 2 square, 3 square until n square. Okay, if I need to add any terms of this series, you need to follow this Sn formula. This is the formula of Sn. 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 You can find S2, S3, S4, just substitute here. You can find this. For example, if I need to find S100, instead of adding 100 terms, just substitute n by 100 here. This is a general formula for Sn. Now I will use this one to evaluate, for example, 20 terms of this series. I need to evaluate because here the addition from r equal to 1, r square until 20, r square until 20. So to find this one, r square from r equal 1 until 20. So instead of adding 1 square plus 2 square plus 3 square until 20 square, I will just apply the formula here. 1 over 6. This will be equal 1 over 6 multiplied by 1 over 6 multiplied by n multiplied by n plus 1. So n here is 20. N here is 20. So multiplied by 20, 20 plus 1, n plus 1, and 220 plus 1. 220 plus 1. 220 plus 1. 220 plus 1. So you can evaluate this one. You can evaluate just direct substitution. I need to add the first 20 terms. I need to add the first 20 terms. So what I need to do, I just, instead of adding 1 square, 2 square, 3 square plus 4 square until 20 square, you just apply this formula. You just apply this formula. 1 over 6, 20, 20 plus 1, 2, 20 plus 1. Just apply the formula here. Same for r cubed. I need to add the first 25 terms for this one. So what I will do, I will just apply the formula. R from 1 until 25, r cubed. So it will be equal to, according to the formula, this one. N plus 1 over 2 square. N is 25. N is 25. So 25 plus 1 over 2 square. Over 2 square. You can find the answer. So just direct substitute on the formula. Just direct substitute on the formula. Okay, what about here? Direct substitute of the formula by n equal to 25. Okay, here we have this example. R equal to 1 until 10. 2r minus 1. 2r minus 1 squared. So how we can solve this one? How we can solve this one? What we need to do here? Okay, here what we need to do is we need to expand. We need to expand 2r minus 1 squared. So this is when we expand this one, become 4r squared minus 4r plus 1. You need to expand. So you have 4r squared minus 4r plus 1. Minus 4r plus 1. So this will be equal to equal to 4r squared, r from 1 until 10, minus 4 r from 1 until 10 r plus from 1 until 10 to 1 plus until 10 for 1. Okay, for 1. So we need to expand first 4r squared, 4r squared minus 1, and then 4r squared minus 1 minus 4r plus 1. We expand the square first. Then 4 is a constant, summation r squared. We can distribute the sigma here over the addition and subtraction. Multiplication, division, we cannot. So 4 is a constant outside the summation. So r squared minus 4 summation for r and plus summation for 1. Okay, now here for the first one, we need to apply the formula. I will apply the formula for r squared when n equal 10. So 4 over 6, 10, 10 plus 1, which is 11, 11, 2, 11 plus 1, which is 23. 2, 11 plus 1, which is 23. I apply the formula. I apply the formula. I apply the formula here, this one. This one, for r squared. I apply this formula when n equal 10. Now for r, I will apply this formula when n equal 10. When n equal 10. So minus 4 minus 4 for r from 1 until 10, which means that 10 times 11 over 2. 10 times 11 over 2. Plus the summation for 1, 10 times, which is plus 10. Plus 10. Plus 10. Then we can find the answer. If you have any question, you can ask. Okay, these two examples, we have 2 square. We need to find the summation of the series. 2 square plus 4 square plus 6 square plus until 2n square. So we need to find the summation here. So what you will do again, I need to find the summation for 2n square. 2n square. Or 2n square, or make it not sure. 2r squared when r started from 1 until n. So I need to add 2 squared, 4 squared, 6 squared until 2n squared. So here I will up. This means that from the first term until n, 4r squared. 4r squared. So 4 r equal to 1 until n, 4r squared. 4r squared. 4r squared. The last 10, not 1. The last one is 10. Okay, your friend asked here for the previous question. This one plus 10 because we add 1 10 times. R from 1 until 10. So we need to add 1 10 times. 1 plus 1 plus 1 plus 1 10 times, which is 1 multiplied by 10, which is 2. If the constant, for example, 2 or 4, if you have plus 2, then 2 plus 2 plus 2 plus 2 10 times, which is 20. Which is 20. 2 times 10, which is 20. Here, not 1, I add 1 10 times. So it become 10. Should be become 10. Because the addition starting from 1 until 10, how many times you add this number? We add this number 10 times. So plus 10. So here I need to apply the formula. So it become 4 over 6 and plus 1, 2 and plus 1. 2 and plus 1. So this is the general formula for this series. This is the general formula as n for this series. Okay, what about the second example? The second example. This one 1 times 3. This one not 1.3. This one 1 times 3 plus 4 times 5 plus 7 times 7 up to 30 10. This one not this one not point. This one not point. This one 1 times 3. I have 1 multiplied by 3 plus 4 multiplied by 5 plus 7 multiplied by 7, right? Plus 7 multiplied by 7, yes. We need to add up to 30 terms. We need to add up to 30 things. This is not point. This is not 1.3. Because if it is point, you just follow the arithmetic, because it will be arithmetic sequence. So it is, you can follow the arithmetic sequence for n step. Okay, here we have, this is a multiplication, 1 times 3, 1 times 2. I need to find the sum of this series. I need to find the sum of this series. So what I will do here, look for the first numbers. 1, 4, 7. 1, 4, and 7. 1, 4, and 7. 1, 4, and 7, the first number we multiplied is arithmetic series. Arithmetic series, we add 3. We keep adding 3. So an here should be the first term, 1 plus n minus 1d, which is the 3. So you have 1 plus 3n minus 3, which is 3n which will be equal to 3n minus 2. 3n minus 2. This is the first numbers. These are the first numbers here. 1, 4, 7. The first number I multiplied. Now the second number 3, 5, 7. 3, 5, 7. 3, 5, 7. This is the second sequence. 3, 5, 7, and so on. So this is also arithmetic sequence. We keep adding 2. We keep adding 2. So an will be the first term, 3, plus n minus 1, the number you multiplied, which is 2. Which is 2. This is equal to 3 plus 2n minus 2, which means that 2n plus 1. 2n plus 1. So the first numbers here, 1, 4, 7, the first number, 1, 4, 7, arithmetic sequence, we find its nth term. 3, 5, the second, and then 3, 5, 7, another sequence, another arithmetic sequence have its nth term. So what I will do here, the multiplication between these two sequences, the multiplication, I need to add the multiplication between these two sequences up to 30 terms. Up to 30 terms. So you need to find this one. You need to find the summation starting from 1 until 30. For the first sequence here is 3n minus 2. The first sequence is 3n minus 2. Multiplied by the second sequence, 2n plus 1. 2n plus 1. So you have to find the multiplication, the summation of the multiplication up to 30 terms. Up to 30 terms. Which one you need me to explain it again? The second example, or what? Or the one, which one? Example 5, 6, 8. Example 5, 6, 8. This one, 2 square plus 4 square. Okay, this one, 2 square plus 4 square plus 6 square, 2n square. We need to find the series here. 2 square plus 4 square plus 6 square plus 2n square. So I need to add the terms. Here I just change n by r because I cannot use n here and n here. That's all. So instead of writing 2n, I write 2r. Now r here from 1 until n. From 1 until n. Okay, from 1 until n. So you need to add from 1 until n the sequence 2n square. The sequence 2n square. You need to add from 1 until n. So you have a series now. You have a series now. So I just expand. 2 square become 4. R square. 4r square. 4 is a constant outside. 4 is a constant outside. Here we have r square. Now r square, this one, r from 1 until n, r square, I just apply the formula here. This one. So I substitute between, instead of r square from r equal 1 until n, I instead this one. So become 4, you have 4 from the beginning, from a multiplication, over 6 n plus 1 to n plus 1. So this sequence, the general Sn terms, this one. If you need to find S10, I mean from r equal to 1 until 10, just substitute n equal 10. Just substitute n equal 10. That's. Now for the second example, 1, 4, 7. This one, I have a multiplication between two sequences. The first sequence, arithmetic, we have an. The second sequence arithmetic also we have an. So it is a multiplication between two sequences. Between two sequences, we need to find a summation from 1 until 30. From 1 until 30. So this one will be equal to, now you need to multiply. Now you just need to multiply. So it will become summation from r equal 1 until 30. 6 n square minus, no, minus 4n plus 3n, which is minus n minus 2. Minus n minus 2. So 6n square minus n minus 2. So this is will be equal to 6 r from 1 until 30 to n square minus r from 1 until 30 to n minus 2 from r equal 1 until 30. Until 30. Now you need to apply the formulas. You need to apply the formulas. So 6, applying the formula when n equal to 3. So 6 over 6, 30 multiplied by 31 multiplied by 61. 2 times 30 plus 1. Okay, for this one, we apply the formula. For this one, here I have n equal 30. So I will go back to the formula here for r square. I will make n equal 30. N equal 30. I will apply. So 30, 31, 30 plus 1, which is 31. And 2, 30 plus 1, which is 60 plus 1, which is 61. This is what I did here. Now, minus n from 1 to 30. So I will apply the formula of n. The formula of n, which is 30 multiplied by 31 over 2. Here we apply the formula of n. Here we apply the formula of n. This one. We apply the formula of n. This one. N is 30. N is 30, 31 over 2. And minus 2 is added 30 times. 2 is added 30 times. So 2 times 30, which is 60. 2 times 30, which is 60. So minus 60. So this is how you can evaluate this one. This is how you can evaluate this one. So what I did here again, I have 1 times 3, 4 times 5, 7 times 6. So I have a multiplication between two sequences. The first sequence, 1, 4, 7. So 1, 4, 7, this is have arithmetic sequence, have its own nth term, which is 3n minus 2. The second sequence, 3, 5, 7, and so on, also arithmetic sequence. So you need to apply am, which is, you need to find its nth term. Nth term is 2n plus 1. Now we have to multiply the nth term for the first sequence by nth term for the second sequence. And you need to add up to 30 terms. According to the questions, we need to add up to 30 terms here. So your addition will start from the first term until 30 term. 3 and the first nth term of the nth term of the first sequence and the nth term of the second sequence. Do the multiplication, you have 6n squared minus n minus 2. Now substitute and apply, distribute and apply the formula. So this is your answer. If you have any question,